Welcome back to this discussion on useful operators. There are many useful operators and built-in functions that we haven't really had a chance to discuss yet. This lesson is going to serve as that chance to catch up and explain these few concepts that didn't really fit perfectly into the other previous topics. We'll discuss useful operations as well as some built-in functions. Let's open up a Jupyter Notebook and show you what we're talking about. The first thing that we're going to discuss is the range function. And the range function allows you to quickly generate a list of integers. This comes in handy a lot, so take note of how to use it. Let's imagine that I wanted to iterate through a list of 100. So 100 integers from 0 to 100. Well, one option would just be to say for number, or num, in, and then I would have to create that list, 1, 2, 3, all the way to 100. That's a lot of typing for me to do, so instead of doing that, what I can use is the range function. And the range function takes in your starting index and then the index you want to go up to. And recall from slicing, we went up to an index but did not include it. So if I want to print out the numbers from 0 to 10, I'm going to go up to 11. That is not including 11, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 11. And then I'm going to print the number. And here I can see 0, 1, 2, 3, etc. all the way to 10. And similar to slicing, there's actually a step argument we can provide as well. So if we want to just go in jumps of 2, I can provide a third argument, 2, and that's the step size. So this is a way to quickly get even numbers, or if I wanted, for example, to take a step size of 5 and go all the way to 100, I could do from 0 up to, but not including 101, in steps of 5, print out all the numbers. So now I can see I've printed out in steps of 5, 5, 10, 15, 20, etc., all the way to 100. So that's really useful for iterating. And what is really nice about this is that it's actually a generator. So this is not saving a list in memory. It's basically just saving out a formula and the previous number. So it remembers that you're starting at 0 and it needs to add 5 to get to the next number instead of having to save a huge list in memory. That way, in case this is a really large number, maybe 10 million or 100 million, it's not saving 100 million elements in memory. Instead, it's saving the formula, go from 0 in steps of 5 up to whatever number this is. So because this is what we call a generator, and it's essentially saving that formula, if we actually just call range by itself, and let's make this number a little more manageable, and we'll go ahead and delete the step size. If we just say range 0 to 10, and hit enter here, we just get back range 0 to 10. And if I try to print this out, I will get the exact same thing, range 0 to 10. If I actually want to get a list and generate the full list, I will need to transform this by passing it into list. And notice the amount of parentheses I'm using here. 1 is for range, the starting and the ending. So this would be 0 through 9. And then we see the list, and then we see print. And now I can see 0 up to but not including 10, so then I get 9. That's the range function. It's very useful. Another very useful function, especially for for loops, is the enumerate function. Let's say we are going to iterate through a string. So we say for letter in, and then I will say A, B, C, D, E, print the letter. So here I see A, B, C, D, E. Imagine that I also wanted to print the index that corresponds to each of these letters. What I could do is the following. I could say index is equal to 0, and then say print letter, and I will actually use some formatting here. I will say at index, curly braces, the letter is, curly braces, and the string, say dot format, and I'm going to essentially inject the index, the letter, and then off of index, I'm going to set that equal to index plus 1. So note what I have here. It says at index 0, the letters A, 1, letters B, etc. So I start off with the index being equal to 0, and then for every letter in the string A, B, C, D, E, I'm going to be using print formatting to print out the index and the letter variable. And then once this is printed, I will go ahead and add 1 to the index. And as a quick note, since this sort of action is really common, adding 1 or subtracting 1 or even multiplying a variable by its previous value, The shorthand for a variable is equal to the variable plus its some other value is the following. Instead of saying index equal to index plus 1, I could just say plus equals, and that's actually the exact same thing. So then when I run that, I get back the same result. So that's a shorthand. Now, there's even a better way of doing this, and that uses the enumerate function that I was just discussing. So let's see how we could do this with enumeration. I will say for, and then I will use tuple unpacking that we discussed earlier. And there's essentially a count variable returned in this, as well as a letter, or whatever you happen to choose as your temporary variable name. And then we can say enumerate A, B, C, D, E. And then I could essentially use the exact same thing. So I will copy this, paste this, and we can actually, instead of using count, we can use index. Again, you can call these variable names whatever you want. And then when we run this, we get back the exact same result. So what is actually happening with enumerate? Well, let's grab it and pass it into a list so we can see the result. We'll say list, pass in enumerate A, B, C, D, E, run that, and notice what's happening. It's generating a list of tuples, where the first item in the tuple is a numerical count. This sort of operation is really common as you begin to program in Python, where you're going to want to not only iterate through some sort of list or string or any sort of iterable object, but you're also going to want to keep a count of where you are at. And enumerate is a very convenient way to do that. And especially when combined with tuple unpacking, you have a really powerful piece of code all nicely in one line. So with the enumerate function, you're able to create a list of tuples where the first item in the tuple is the count of what stage you're at in the iterable, and then the second item is the iterable itself. So you could also do enumerate with not just a string, but you could also do a list. So you could say A, B, C, run that, and you would get the exact same thing. So notice it just works for any sort of iterable object. You get back an index and letter, and it works the same way. As you begin to learn more about Python, you'll start to realize that this sort of list of tuple format is actually really useful. And maybe you're going to have multiple lists that you want to zip together or join together in this sort of format. Well, you can do that easily with the zip function. So I will create two lists here. My list 1, which is going to be the numbers 1, 2, 3, 4, 5. And then I will create my list 2, which will be a series of letters. We will say A, B, C, D, and we want to make sure they match up, so we'll go to E. So right now I have my list 1 and my list 2. If I wanted to join these together in order to have tuples of these pairs, 1A, 2B, 3C, what I could do is use the zip function and say my list 1, my list 2, and then I can actually iterate through this. So now I can say for item in zip my list 1, my list 2, print the item, and notice what happens here. It's actually creating a list of tuples based off these lists. And let's imagine I'd said zip up my list 2 of my list 2, then I would just get AA, BB, CC, CC. What I can also do is if I just want the list itself, I can transform the result of that list or that zip function by passing in list. Again, zip, all it does is essentially it's acting like a zipper on a jacket and zipping together these lists. You'll want to keep in mind though, if you have more items in one list, so let's make my list 1 longer than my list 2, and if we try to run this here, it'll only go as far as the shorter list. So you won't get an error, but you'll only go as far as the shorter list. So when it's zipping up, it's going to cut off anything else in the other list that's longer. Keep that in mind as you use the zip function. The next operator we're going to discuss is the in operator. We've already seen the in operator here in the context of a for loop, but you can also use it just outside of a for loop to check for something being inside a list. So we can say x in the list 1, 2, 3, and it will return back a Boolean, false, because the string x is not in this list. And we can also check if x is in this list. We'll say a, comma b, comma c, and this returns false, but let's change one of these to be x, and now we can see it's true. It actually also works for any iterable object, and it will work for strings as well. So we can say A, B, C, D, E, that returns false. So we'll say is x in A, C, X, and we get back true. Essentially, it's kind of a shorthand of a quick for loop check to see if this object is in any of the iterable elements of a string or a list, or really any sort of iterable sequence. So again, that's the in operator. Hopefully you can see how it's related to the in operator use in a for loop. Essentially just checking if something is in some iterable object. Next up, we want to discuss the min and max function. They basically allow you to quickly check the minimum or maximum of a list. So if I create a list, 10, 20, 30, 40, 100, I can use min. Notice how there's syntax highlighting there. That can grab quickly the minimum of a list, or I can say grab the maximum of a list and it turns back 100. Python also comes with a built-in random library. There's lots of functions included in the random library. We're just going to show you two useful functions for now, and that is the shuffle function as well as the random integer function. And to import particular functions from the random library, you can say from random import, and then if you hit tab here, you should be able to see a bunch of options that you can import. We're going to import shuffle from the random library. We'll say from random import shuffle. And this means now that we've imported shuffle function from the random library that's built into Python. We'll discuss this syntax in a lot more detail when discussing creating your own modules or own packages. For now, let's go ahead and see how we can use this shuffle library. Shuffle allows you to shuffle the list in place, meaning it's not going to return anything. Instead, it's going to affect the list that you pass into it. So before I actually run this, I'm going to show you my list, which is in order, and then I'm going to call shuffle on my list, and the shuffle is happening in place, meaning if I check my list again, it's been permanently shuffled into some other order. And then I can also reshuffle it again, my list, and it's now going to be shuffled in some other random order. So now 20, 10, 40, 100, etc. So that's how you can use shuffle. The other function we want to show you from random is the rand-int, or random integer function. And you can import that as well and say rand-int, and this returns a random integer in range a to b, which including both endpoints. So I can grab a random number from 0 to 100, and then it will return a number from 0 to 100. So here I can see 30. Let's go ahead and run it again. 53, 46, and you can keep running this and you'll get random numbers, and you can make the range even larger to make it more obvious that they're random. For now, let's wrap up our discussion by quickly discussing comparison operators and logical operators. We've already talked about comparison operators, but let's formally just go over them. Comparison operators allow you to compare two objects, so I can say is 1 less than 2, and I get back a Boolean value. More importantly, we can also check for equality. So I can check is 1 equal to 1, and that returns true. It also has to be the same data type, so I can say is the string 1 equal to the integer 1, and that will return false. And for inequality, it's going to be exclamation mark or exclamation point equals, and then that's not equal to. So is 1 not equal to 2? Well, that's true. 1 is not equal to 2. So those are comparison operators, and you can look back at the previous lessons to see what we discussed about other things, such as greater than, less than, greater than or equal to, etc. But let's imagine that we now know about comparison operators, but want to combine multiple comparisons. We can use logical operators in order to do that. And there's essentially three major logical operators. There's the AND keyword, the OR keyword, and then the NOT keyword. Let's start off by looking at AND. So I'll say 1 is equal to 1 and 2 is equal to 2. And when I run this cell, I get back true. So what's actually happening here? The AND keyword requires that both statements be true in order for it to return true. So let's make one of these false by saying 2 is not equal to 2. And when I run this, I get back false. So that's the AND keyword. And you can also keep adding on more. So we can say and 3 is equal to 3. So if we change this to all be equal, we end up getting true. However, we should be careful to stack up too many of these, especially because it makes your code a lot longer and it then becomes more difficult to track out your logic. So that's the AND keyword. There's also the OR keyword, and in this case, it's only going to need one of the statements to be true. So we can say, is 1 equal to 1, or is 2 not equal to 2? And this returns true because this first one happens to be true, even though this second one is not true. So to make it more obvious, is if we say, is 1 equal to 1, or is 2 equal to 100, it only needs one of these conditions to be true to operate. Finally, we have the not operator, and the not operator can be thought of as reversing the Boolean it's given. So if we have 1 is equal to 1, that returns true. If we write the keyword not in front of it, it will say false, essentially reversing the Boolean it's given. So let's show you a more realistic example of when you may want to use this. We will say answer is equal to no, and then we'll say if 1 is equal to 1 and not answer equal to yes, print success. So when I run this, I see success, because what's actually happening here, I'm checking this condition first. If 1 is equal to 1, well, that happens to be true, and the answer is not equal to yes. Then I print out success. So since the answer was no, I get back success. Another way to do this is, instead of using the not keyword, just to use an exclamation mark, and that's the exact same thing. All right, those are a bunch of operators that you may find yourself using. Hopefully they were helpful to you in your studies. Thanks, and we'll see you at the next lesson.